Hello everyone, welcome to Geeta's classes. Today we are going to see Poisson distribution as a limiting case of binomial distribution. What is binomial distribution? It is a discrete distribution we know, and for binomial what is the PMF? That is probability mass function P of x is equal to x is NCx P per x Q per n minus x, where x takes the value 0, 1, 2, 3 etc. up to n. Okay. Bernoulli trial is repeated for how many times? N times. That is NCx. Okay. There is finite number of times the experiment is repeated. So only for finite. N can take the values of finite integers only. Now, what about Poisson distribution? PMF is P of x is equal to x is e per minus lambda into lambda per x by x factorial, where x can take the values 0, 1, 2, 3 etc. up to infinity. See, when n becomes very large, we are going to use Poisson distribution. So in binomial, it can take only up to n, finite n values only. But in Poisson, it can take infinite number of values. That is the main difference between binomial and Poisson. That is why Poisson is now we are going to see the derivation as Poisson distribution as a limiting case of binomial distribution. That is, as limit n tends to infinity and p tends to 0. That is, p will become very small, n will become very large. Then binomial will become Poisson distribution. That's what we are going to see in this derivation. And this derivation was asked in the last year examination for 5 marks. This derivation is very, very important. Okay. So let us see this. How can we derive this? We are going to derive this under some condition. That is, I told you already, p is very small and n is very large. And NP is what? The mean of the binomial distribution. Binomial distribution mean is NP. And for Poisson distribution, mean is lambda. So here mean is lambda. Okay. So let us assume this NP is equal to lambda. Okay. Is finite. It is not infinite. Lambda is finite. Now from binomial distribution, what do you know? That is P of x is equal to the PMF. P of x is equal to NCx P per x Q per n minus x. Right? Where x varies from 0, 1, 2, 3 etc. up to n. I am going to expand this. How we can expand? I will tell you one example. See, 10C3 if you have. How will you write? 10 into 9 into 8. Right? 3 times. Why? This is 3. So, into divided by 1 into 2 into 3 we write. That is 3 factorial. Right? So, up to this NCx I am going to expand like this. N into n minus 1 into n minus 2 into etc. n minus of x minus 1. Is it correct? How? See, n minus of, this is the general term. N minus of x minus. Check here, 10C3. So this 8 will be 10 minus of x is 3. So 3 minus 1 is 2. So 10 minus 2 is 8. So till that term we have to write. So the last term in this series will be n minus of x minus 1 divided by x factorial. Okay. Into p per x into q also I can write. We know that these distributions p plus q should be equal to 1. Okay. So p per x into q also I will write it as 1 minus p the whole power n minus x. Okay. Now substitute np is equal to lambda. That implies n is equal to lambda by p. Replace all the n by lambda by p. Okay. Now let us take this equation as equation number 1, and we are going to substitute this value in equation number 1. Therefore, equation 1 becomes what will you get? P of x is equal to n into, so lambda by p into n minus 1, right? So lambda by p minus 1 into lambda by p minus 2 etc. lambda by p minus x plus 1 whole divided by x factorial into p power x into 1 minus p the whole power n divided by 1 minus p the whole power x. How? See, I have this term, right? N minus x. 1 minus p the whole power n minus x. I have written it as 1 minus p the whole power n. That is the positive term. I have kept it in the numerator, and in the denominator minus x I have brought. That is a power m minus n can be written as a power n m by a power n. This, using this formula only I have written this. Okay. Therefore, now lambda you keep it as it is. Okay, all the p, you take LCM in each factor and bring all the p to the denominator. So lambda into first term, that p I'll write later, and in this term lambda I have lambda by p minus 1 can be written as lambda minus p by p, right? So lambda minus p, and in the second term what you have, lambda by p minus 2. Therefore, lambda minus 2p divided by p, right? So, that denominator p I'll write later together. Lambda minus 2p and so on. Lambda minus of x minus 1 into p, right? Divided by x factorial is already there, and p I have to write. How many p's are there? 1, 2, 3, etc. up to this is x minus 1. And one more p here. So x. Okay. So x times p. So p power x into p power x into 1 minus p the whole power n by 1 minus p the whole power x. So this p power x and p power x terms will get cancelled. Now this is equal to lambda into lambda minus p into lambda minus 2p etc. lambda minus of x minus 1 into p the whole divided by x factorial into p power x is gone. Now this p, for my convenience I am going to write this p as lambda by n. We know that what is the substitution? Np is equal to lambda. Right? So that implies p is equal to lambda by n divided by this 1 minus p. I will keep it as it is. Right? Now let n tends to infinity and p tends to 0. I am letting n tends to infinity and p to tend to 0. What will you get? Lambda, see, as p tends to 0, this will become 0, this will become 0, this will become 0. All these p terms will become 0, right? Therefore, lambda, so p of x is equal to lambda into lambda minus p. P tends to 0, so 1 by lambda, 1 more lambda, etc. How many times? X minus 1 times, right? And 1 more lambda here. Therefore, x times. If you want, I'll show you here 1, 2, 3, etc. x minus 1 and 1 more lambda here. That is why x times divided by whole divided by x factorial into limit n tends to infinity. What is the next term? 1 minus lambda by n. Sorry, here again I forgot this power n. Okay. 1 minus lambda by n the whole power n. 1 minus p the whole power n. I forgot this n, so power n. So 1 minus lambda by n the whole power n, right? So limit n tends to infinity. 1 minus lambda by n the whole power n. And limit p tends to 0. 1 by 1 minus p the whole power x. Okay. So this is equal to how many times? Lambda per x, right? X times. So lambda per x by x factorial into what is this term? You have already studied in M1 sequences series. What is this limit? This is nothing but e power minus lambda. Limit n tends to infinity, 1 minus lambda by n, the whole power n is e power minus lambda. And limit p tends to 0, this will become 0, 1 power x, therefore this is also 1. That is e power minus lambda into lambda per x by x factorial. What is this? This is p of x. This is the PMF of our Poisson distribution. Okay. We started with PMF of binomial distribution. As n tends to infinity and p tends to 0, that is, as n is becoming larger and p is becoming smaller, it will approach Poisson distribution. This is the proof. Okay. The proof is very, very important. Please study that. Okay. Thank you so much for listening. Thank you.